In this session we look at cables and plugs. The role that the national grid plays in delivering electricity, the difference between live, neutral and earth wires, and safety devices that are built into the electrical systems. First pause the video and try the Do Now task. Let's check our answers. What is the voltage, time period and frequency of this alternating current? We can see that from the center the height of the wave is 1, 2, 3 squares. Now each square in height has got a voltage division of 8 volts, and we've got 3 of those squares. So 8 times 3 is 24 volts is the total voltage. The time period can be worked out by looking at the length of the wave, and one wave is 4 squares long, and each square has got a time base of 5 seconds. So that means the time period is 5 times 4, so it's 20 seconds. The frequency can be worked out by doing 1 divided by the time period. So if the time period is 20, 1 divided by the 20 is 0.05 Hertz. Let's first look at the national grid. The national grid is a network of wires and transformers that distribute electricity across the country. Electricity is produced in power stations and will have a voltage of around 25,000 volts. If we send this voltage of electricity out to the country, we'll have quite a large current, which will mean that we'll produce a heating effect in the wires, and that'll lose a lot of the energy that we're trying to send. So to distribute the electricity, we need to raise the voltage and lower the current. So before we transport it, we send it through a step-up transformer. And the step-up transformer cracks the voltage up to 132,000 volts. And this brings the current all the way down, so it reduces the heating effect in the wires. We carry the electricity through transmission cables, and then when we get to the towns and the cities, we need to lower that voltage and raise the current so that we can send it into people's homes and offices. So to do this, we use a step-down transformer, and the 132,000 volts will be stepped down and become just 230 volts. But this raises the current that can then be used inside homes and offices. Now pause the video and complete task 1. Let's check our answers to task 1. What is the national grid? It is a system of cables and transformers that distribute electricity across the country. Add labels to the diagram. We have the power station producing a voltage of 25,000 volts, then a step-up transformer, and the transmission cables that carry a voltage of 132,000 volts. Then we've got the step-down transformer, and then the homes and offices are getting a voltage of 230 volts. Let's now look at the type of wire used in the home. We have 3 wires: the live, the neutral, and the earth wire. The live wire is the wire which brings electricity into the property. This wire is coloured brown and usually carries an alternating current and a voltage of 230 volts. To carry current away from the property, we have the neutral wire. And this is a blue wire, and it runs from the property under the ground to a substation. And when it's at the substation, then the electricity is grounded. Let's have a look at how we wire a house. A live wire, the brown wire, is carrying 230 volts and an alternating current in from the power station. We place a fuse box on the live wire so that if too high a current enters the property, the fuse can blow and it will cut the electricity entering the property off. We also require a wire to take current away from the property, so this will be the neutral wire. This is grounded at the substation. All sockets in the house have to be connected to both the live wire and the neutral wire. We usually connect the live wire to the right hand side and we'll connect the neutral to the left hand side of the socket. This means anything plugged into the socket will now make contact with both the live wire and the neutral wire. This will allow electricity to enter through the live wire, power the device, leave through the neutral wire and complete the circuit at the substation. The earth wire is a safety wire. It runs from the outer casing of an electrical object through the top pin of the plug socket and straight to the ground. This means if ever the live wire comes loose and makes contact with the outer casing of an electrical object, it is instantly grounded and should reduce the chance of somebody having an electric shock. This wire is coloured yellow and green. Now pause the video and complete task 2. Let's check our answers to task 2. 230 volts alternating current is coming in from the power station and that will pass through a fuse. The live wire is the brown wire, the earth wire is the green and yellow striped wire, and the neutral wire is the blue wire. The electricity then leaves through the neutral wire and is grounded at a substation. Let's have a look at electrical safety devices. A fuse is a thin piece of wire inside a glass capsule. It will only allow a certain amount of current to flow before it starts to burn. By changing the thickness of the wire, we can decide how much current we wish to flow. We place a fuse before the live wire in a plug. This means that if too high a current enters the plug, then the fuse will burn and stop the electricity from passing into the electrical device. This device prevents overheating, fires, and electric shocks. A fuse box is usually located in a house. We attach this to the live wire, so if too much current is brought into a property, the fuse will blow, and this again will prevent damage or fire. A modern house may have a circuit breaker or an RCCB rather than a fuse box. A circuit breaker is an electromagnet that has been placed in series with a live wire. When too high a current flows, the electromagnet produces a strong magnetic field and pulls open a switch, cutting off the circuit. The advantage of this is that you can turn the circuit back on with the flick of a switch. An RCCB, or a residual current circuit breaker, constantly monitors the current travelling through the live wire and the neutral wire. It will then cut off the current when the live wire current is different from that of the neutral wire. Now pause the video and complete task 3. Let's check our answers to task 3. Question 1, you have to label the parts of the plug. The missing labels are on the screen now. We have the earth wire, the neutral wire, the cable tie, the live wire, and then the fuse. Explain how the fuse works inside the plug. A fuse contains a thin piece of wire. When too high a current passes over the wire, it burns, cutting off the current. Question 3. What is a fuse box? The fuse box is attached to the live wire. When too high a current is drawn into the property, the fuses in the fuse box will burn, preventing overheating or fire. How does a circuit breaker work? We have an electromagnet in series with a live wire. If too high a current flows, the electromagnet pulls the switch open and shuts off the current. How does an RCCB work? It monitors the current flowing through the live and neutral wires, and if the current is different, then the RCCB shuts off the circuit.